Hello, everyone. Thanks for joining us live today for this session on Azure API Management Security Controls. I'll be presenting today along with a fantastic colleague of mine, Andre Davis. To
Hey
introduce
folks.
myself, uh, this is Srini Padala. I'm an engineer and the fast track for Azure team, specializing on app modernization, platform as a service, cloud native, and many more. I'll let Andrew introduce now.
So hey folks, my name is Andre, and as Rin said, I also an application developer specialist here as a software engineer in Microsoft Fast Track, and I'm glad that I'm here with you today to talk about API management security controls. Back to you, Srini.
Thanks, Andre. We also have another colleague of ours, Bappaditya Banerjee, as a moderator for this session today. Feel free to say hi to him. Have your questions coming? He's there to answer all your questions. Have a good time here. Thanks, Bappa, for your support. Moving on, we have a list collection of articles curated to outline the concepts we're going to speak today. It has fantastic demos in that. It has hands-on sessions. Feel free to refer to that content on demand. You can scan the QR code. You'll have the link in the comments as well. Talking about this session especially, right? We want to look at what the learning objectives for these sessions are, right? We've spoken about introduction to Azure API management last week. If any of you haven't attended that session, feel free to go back and look at our Microsoft Reactor channel on YouTube. We have the video there. It talks about the detailed concepts of what API management is and how it supports the API lifecycle throughout. And this specific session, we want to focus on the security aspects of API management, including all the components of API management. So end of the session, you should understand most of the security knobs that are applicable for API management. Looking at a quick agenda, we'll go over Azure API Management overview. It's kind of a little repetition from the previous session. For those who haven't attended the previous session, we'll talk about API management. In a nutshell, we'll look at what API lifecycle is, what networking is, right? Because when we're talking about API management, it's not just the APIs, it's the service as a whole. So we will look at how Azure supports secures the networking of API management and dive into the different components of API management, how we're going to secure each of the components of Azure API management. Right. So let's get started. So what API management is, right? APIs, if you're familiar with APIs, they have been a great construct to allow developers to create complex functionality quite easily, right? It's so popular. Because of its popularity, what happened was organizations easily ended up in a ocean of APIs in a very short time, right? They piled up quickly, and there was suddenly a need for specialized tools to manage these APIs, to manage the complete life cycle of these APIs, observe them and monitor them. So these tools comes under the API management category, and Azure API management especially focuses on the end-to-end lifecycle of API management, integrating into the rich Azure services that Azure provides, as well as it also supports hybrid and multi-cloud capabilities as well. So, though if you have deployed an API management in Azure, though it might look like a single service, it's a group of components coming together for us to accomplish the various tasks of API management. Let's quickly have a look at what are those components that makes API management. There are three key components. There's a management plane, which is kind of the brains, which manages the and orchestrates the whole of API management. And there is a user plane, which is where certain personas interact with API management. And then finally there is a gateway, which is kind of the heart of it, where the APIs are being served on. And each of these planes are specifically targeted at certain user personas. If you see on here, there are three different personas we will be talking about. We'll be talking about API providers who are actually the creators of those APIs. They ideate the solution, they ideate the whole API structure. They'll create an abstract of it. They'll evolve that API with added functionality, and they have the responsibility to secure it. And once they publish it, once the API starts getting consumed, they continuously observe it, and evolve again or iterate again. And there's possibilities of monetization of those APIs as well. So these user personas are primarily interacting with the management plane uh, through a variety of tools, right? They can use infrastructure as code, or they can go to the Azure portal and interact with API management. They can use Azure CLI, Visual Studio Code, so on. So this persona is the ones who are actually creating those APIs for consumption. Now, there's a second persona, which is the app developers. These are the people who actually consume your API in their apps. They develop their apps by using the APIs which the API providers are providing. So these app developers, in the first place, they need to discover these APIs. They need to know the existence of a particular API that is offered by you as an API provider. And once they discover that API, they want to know more about it. They need to read more about it, try it, and then finally onboard them their applications into using those APIs. So there's a specific set of activities that these developers would perform, and there's a specific plane within API management which facilitates the interaction between the app developers and your API providers. We call that developer portal in API management. And the third persona are the actual consumers, right? The people who are using using the apps. They use the apps, be it be a web app, mobile app, IoT, or it could be a native app. These apps, on behalf of the user, interacts with the gateway, which serves the backend API, which is the workload back to the customers. So we have three different personas interacting with three different components of Azure API management, and all combined makes Azure API management. You can also see the rich integration that Azure API management offers into Azure. It has monitoring tooling, security tooling, networking, firewalls, Active Directory, Key Vault, and messaging. So it interacts with a variety of Azure solutions natively to bring that comprehensive API management solution. In a nutshell, this is what API management is about, right? It is helping us combine all the personas required in the entire life cycle of an API, and realize that management here. So we have been talking about API lifecycle. So what exactly is the API lifecycle, right? We have talked about this in greater detail in our previous session, outlining the activities that are performed in each of these circles in here. Just to brief here, the whole lifecycle starts with designing the API. So you ideate an API. You think that, hey, this is what my API is going to be, right? At this point of time, you might not have the actual implementation of the API, but you might have a skeleton there, right? You would actually mock it, make it available, or you can import it from other Azure resources as such. So this is the design phase of the API lifecycle. And we move on. Once we design it, we evolve that API with with developing that into a full-fledged API definition. It could include using the 50 plus Azure the policies that API management offers across different categories, like abstraction, caching, and so on. And it also provides all the development capabilities, right? Visual Studio Code integration, right? You can debug the policies as you create your API and scaffold them and so on. So post design, you actually evolve the API, develop it into a full grown API, and then move on to the phase of securing that API. This specific stage is about securing the API in subject here, right? Though the session is about talking the holistic security, 360-degree security on across the service as well as the APIs, but this stage of the life cycle is more focused on how do we secure that API, right? How do we validate it? How do we ensure that there is appropriate authorization and authentication applied on top of this? So this is where all that security aspects comes into play, and we are going to go deeper into this today, and how you're going to secure API using different techniques that are possible within API management. Once we have all these dots connected, we are ready to publish our APIs and make it available for the app developers. That's where we actually publish that in when developers discovers that, put it into promote that into higher environments and so on and so forth. And from here, the infrastructure part starts, right? Once we publish it, we could publish it, make it available across geographies, right? It could be an hybrid model where the APIs can be made available in your on-premise as a self-hosted gateway, or for that matter, it could be in a different cloud as well. So it provides that global scaling approach where it's not just Azure, but it can be anywhere in any kind of infrastructure that you would like. Once we have the APIs being consumed, we want to monitor those APIs in a continuous fashion. Right? We want to look at how the APIs are doing, what are being used, what are not being used. If there are any errors there, how do I improve that whole thing? So this is what the monitoring aspect of it is. Right? We have variety of integrations into Azure management solutions like Azure Monitor, Log Analytics Workspace. We have application insights. There are inbuilt tools like API Inspector and so on. And while we monitor, we capture a lot of insights, and all these insights are available for us as reports. You can build reports, or there are custom reports that could be built on top of these metrics. There are reports analytics available within API management, which you can continuously analyze and improve where you are lacking. Maybe an API is not performing better, you can look at it, seeing which one is taking a lot of time. Or you can see that, okay, this particular API has a lot of traffic, maybe you need to scale that better. So you can make informed decisions on how you can improve your API and go through the cycle again. So this is what the full API life cycle is, and from design to analyze, and then again going back to the design, and the cycle continues. Moving on, so now that we understand at a high level what API management is about, let's look at how when it comes to security, what are the different aspects we need to consider when it comes to API management. So we talked earlier that we have three key components in API management. We have the management plane in itself, we have the developer portal, and we have the gateway, and each of them interacts with a specific persona, and we need to make sure that each of these is secured for all the kind of traffic that flows in. For example, if you're taking the apps itself, they interact with the gateway. They interact with the gateway. There is an ingress to the gateway, there is an egress to the gateway. You need to make sure that we protect the inbound connectivity as well as the outbound connectivity, both from an access perspective, networking perspective, the protocols perspective. There are a lot of aspects we need to look into when we are talking about security of a particular traffic. Then the management plane, right? Though the management plane is targeted only a few set of users, we need to ensure that this is secured enough so that only the API providers could access that and kind of negate any kind of a malicious intent on it. And last but not least, you also have to secure the user plane, right? We need to securely allow access to the app developers, especially when it comes to monetization, right? If you are selling your APIs, you need to make sure that the app developers have their information secured enough in terms of what APIs they're subscribing to, how they are doing it, how they are logging into the system, how they are monitoring, and so on and so forth. So we'll talk about all these four aspects here: the management plane security, the user plane security, the gateway security, both inbound and outbound, throughout this session. And at the end of this session, we will have detailed knowledge on how we can secure each of these planes that are within API management. So when we're talking about API management as a service, all right, the first thing that comes into mind is, hey, API management is an Azure service. So obviously it needs to have some kind of networking integration into your organization, right? Your organization will have a private network, and you want to see how API management plugs into your private network and be able to serve the APIs that are available in your private network. So for that reason, API management offers three networking modes. I can quickly show you in the portal. So when you go about creating an API management instance, let's look at creating an API management instance here. So when you click on create here, and we'll quickly go into the network tab here. So there are three options that are available here. There's a none option, there's a virtual network option, and the private endpoint option. uh, the none option is primarily saying that, hey, I don't want any virtual network connectivity, right? What it essentially means is the inbound is publicly available, and this API management instance can access only internet routable backends. So this is primarily used in cases where you want to expose SaaS services or services which are publicly available to your end users in a secure way. So this is typically what none means, where we are not talking about any API management here. The private endpoints again is about a similar concept, where you use private endpoints of API management to expose your API management instance, and it's relatively new and it has its own limitations. Our focus today would be on how I can integrate my API management into my virtual network, right? You might have your own virtual network, and we offer two different modes for integration of virtual network integration for API management. There's an external mode and the internal mode. There's a lot of overlap between them. So if you talk about the internal mode is about completely making the API management secured within your virtual network. It is discoverable only within your network and not anywhere outside. And it has the capability, because it is integrated into your virtual network, it has the capability to talk to the backends within your virtual network. They could be within in the Azure, in your virtual network, in your Azure resources, or it could be on premise, where you are connected through a site to site or an express route VPN. The external is a kind of extension to the internal, where it is still injected into the virtual network for all backend communication, but at the same time it is also publicly available from an ingress perspective, right? It has a public ingress there. It takes public traffic, as opposed to an internal only, where it can take only where it can only take the uh, private traffic alone. So let me just quickly, just give me a second. Sorry. Yeah. So talking about the visual aspects of how these the different virtual network configurations of API management are wired up. We're talking about the external API management virtual network integration. So this is what it is, right? The API management still resides in your virtual network. It is able to talk to your backends within your virtual networks in a more secure way. It can talk to your on-premise API backends that are hosted in your private data centers, which are connected to Azure through site-to-site VPN or express routes. But the only thing is, it is also publicly available for consumption from the internet. And because this is publicly consumable from the internet, all the DNS entries that you see here, they are hosted by Azure. So all these are publicly routable, publicly identifiable DNS entries there, which resolves to the public IP of an API management instance. Again, this is secure, because we are securing all our backends, private backends, and proxying them through the API management, through the API management instance. A small variant to that is the internal configuration, which is exactly the same as what we have spoken earlier for external, where the internal is more about disconnecting the public access of that API management instance. So we're saying that, hey, users can't reach to my API management through from public internet, because this endpoint is only discoverable within the virtual network. The backend communication still remains the same. It can talk to backends within Azure Virtual Network, or backends that are inside your data centers. And you can see that you as users, your corporate users within your office locations, they use the same tunnel here. They come back through the same VPN and access the API management instance. The only thing that you might notice here is administrators are still being able to access it through the internet. So that's one caveat here, where even if you have an internal only API management instance, you will still need a public IP. You'll need a public IP which is only accessible by Azure. So it's not like open to all. It is the traffic for that public IP is restricted only for Azure resource provider, which will try to which will open up Azure portal communications for administrators to be able to access API management. The, Again, we are working on a no public IP variant of it that's in the works, but for now you still see a public IP. You should not be concerned about that public IP, though you say internal, because that public IP is purely used for internal only traffic. Now, we talked about external only configuration, and we talked about internal only configuration. What about if I need both internal and external access? Say, suppose I might have 20 APIs in my organizations. I would want to serve 10 of them externally and 10 of them internally. So we can modify this architecture to front end that with something like an application gateway. An application gateway is one of our layer 7 load balancing portfolios, where you can front end that with a public facing application gateway talking to an internal only application API management. So this gives us a secure internal traffic route as well as a secure external traffic route, making the best of combining the best of both worlds from the internal only and the external modes. We still have the administrator traffic here for the portal. That's in here, but additionally we will have an application gateway where you can also deploy a web application firewall, right? You can have WAF configured on the application gateway, protecting your traffic for real-time threats. Since this API management is completely internal, you might have noticed that the DNS is no longer managed by Azure, right? It's the user's responsibility to make sure that these DNS are configured appropriately for the internal API management to work. So there's detailed articles on describing as to what each of these mechanisms is, what are the configurations that are required for each of them. In here, if you look at we have articles which talks about how do we configure external VNet throughout this process. How do we configure internal VNet? This is the second pattern we talked about. How do you configure an application gateway in front of an internal only API management instance? Now, there can be a small variance, right? When it comes to organizations, you might want to route all your traffic through your firewall. It might be a requirement. So we can also force tunnel all the traffic that is coming from API management through a corporate firewall, right? We need additional rules. We have documentation which talks about how we force tunnel. How we force channel all the traffic within an internal only API management instance, uh, through your corporate firewall, right? There are certain dependencies, as we looked at in the previous slides. Those dependencies needs to be allowed, and API management. Now your firewall can inspect all the traffic coming into the API management as well as going out of API management as well. Now, from a considerations perspective, right? It's not just enough if you just secure your networking in terms of what what are the components that can access API management, what are the personas that can access API management, right? You always have that risk because there's a public IP on the available for external only, either through the application gateway or through external API management instance. There are concerns coming from corporate security talking about denial of service. So you can enable DDoS protection, Azure DDoS protection on each of the public IPs that are associated with your API management. That even secures whatever the external communication that you have enabled on your API management. And you can also enable the web application firewall on the application gateway. So this ensures that your traffic is monitored on a real-time basis, and you can apply WAF policies. It could be the OWASP policies for web traffic. It could be bot protection, DDoS to some capability, IP filtering, and so on and so forth. There are also certain other considerations which you could make at the service level when it comes to securing your API management instance. There, there are protocols that you use, right? You would use HTTP, HTTPS protocols. You need to make sure that you enable the right protocols, right protocol versions on your API management instance. At the same time, you also need to make sure that your deprecated cipher suits are no longer encouraged within API management. There is a provision for that as well. Uh, I'll quickly go back to the API management instance and show you what are those different knobs when it comes to securing aspects at the service level. Now, in under the security tab in a created API management instance, if you go to the protocols and the cipher suites tab, you will see what are all the different protocols which can be enabled, right? There might be legacy reasons for you to enable a TLS 1.0 or an SSL 3.0. We don't recommend that. Though they are disabled by default. You have the ability to enable those protocols for backward compatibility for legacy reasons. Again, the same goes with the front end as well as the back end, right? If you're talking to a legacy back end, if you want to integrate with the legacy front end, which wants an deprecated protocol, you can enable that as well. Or you can make it secure by making sure that they are all explicitly denied as well. The same goes with cipher suites, right? You have a variety of cipher suites. Some of them are weaker, some of them are deprecated, which are no longer in use. But you might selectively say what are the cipher suites that I wanted to enable or I wanted to disable depending on your organization's security policy. The other thing when it comes to security specific, service specific security is making sure you use certificates across for communication. You want to make sure that you use TLS certificates. Even if you use custom certificates, you can upload your custom certificates here and make sure that all the communication is valid and secured. uh, Managed identities, uh, and management API, right? If you look at this, there's a direct management API which is available in API management, which is used uh, partly in a legacy manner and at the same time mostly in an automation scenarios. We don't encourage you to enable that, but again, if you think that you need automation scenarios where you want access to the direct API management control plane, you can enable that here. But from a recommendations perspective, we always ask you to keep it set to no. That way we are not encouraging direct access to API management and thereby opening an vulnerability here. So essentially we were talking about different considerations here, and we're also talking about recommendations that pop ups time and again, right? Depending on your configuration, if you have done any misconfiguration anywhere, we have Microsoft Defender for Cloud recommendations that pop up time and again, looking at your configuration and advising you with how to go about securing your API management instance. All these are applied at a service level, right? We are not even talking at the API levels, but we are trying to secure our complete API management as a service here.
Srini, one question that I see a lot here. We have also the Azure front door as the other Azure service supports WAF, the web application firewall. Is there any recommendation from you if we can use the front door with API management, or should we keep using always the application gateway? What are your recommendations about the Azure front door plus WAF plus API management?
Yes. So application gateway is more a regional service, whereas Frondor is more a global service. So if you have requirements to have a global, highly available reverse proxy or a layer 7 load balancer within, we can integrate with API management in certain capacity. It's not directly integratable at this moment of time, but we can integrate them with that along with an application gateway. We can have Frondor talking to an application gateway and then application gateway talking to an API management instance. But there's private networking improvements happening in place. That way, we have a private kind of private link enabled API management instance directly integrated into the front door. Keep
Great,
a watch for integrations into front door. But again, the web application firewall is the same across application gateway and front door. If you don't need a global service, application gateway is absolutely fine for you to have it as a regional service. But if you're looking at load balancing multiple API management services across different regions, Frondor is definite candidate, but we need to bypass that through a different proxy at this moment of time.
great, thank you.
Thank you. So now that we understood the how to secure the whole service API management as a whole, right? Now we will look at the individual components across API management. We talked about three components for API management. We talked about the management plane, the data plane, and the user plane. Let's look at how we can secure each of these components and what are all the different knobs that we can enable to secure each of these components. So the first to go is the management plane. As you have seen at the beginning, we have the API providers continuously interacting with the management plane and creating API, securing them. It's kind of the brain of it, right? It can do everything out there. So it's very important for you to secure access to your management plane through appropriate controls. So API management, like any other Azure service, it has access control built into it, right? You can only enable management operations to be done by authenticated users. You can have fine grained permissions based on the roles, right? And all the activities that are performed on an API management are audited, right? If you want to take an audit report for your compliance requirements or your compliance audits, you can always use these logs to look at who has changed what within API management. And we talked about all of them interacting with API management through a variety of channels, right? They can be Azure, coming from Azure portal or the CLIs, PowerShell, SDKs, Visual Studio, whatever be it. The same authentication is applied consistently across the management plane like any other Azure service. We have a set of roles that are defined in API management. Those set of roles, they're built-in roles where you can integrate API management automatically with Azure AD tenant. That's what happens by default when you create an subscription within Azure. All your users are Azure AD controlled, so your authentication is taken care of. And for you to authorize those users to have access to API management, you can use some of the built-in roles that are available within API management. You can either use the built-in roles or you can create custom roles, right? Let's look at what built-in roles are available within API management, right? We have a limited set, but the idea here is to make sure that we provide you the flexibility to create fine-grained roles to suit your particular need. So the primary roles are like service contributor, the service reader, and the service operator, who have certain levels of actions at a high level, but these might not suffice in any capacity. So that's where we always encourage you to decide on what are the user personas that are going to interact within API providers, what other personas you might have, like a DevOps operator, like a developer, or so on and so forth, and see what aspects of API management should be granted access to them. And that can be done by creating custom roles. We have a variety of roles that are possible here for API management through custom roles, right? You have a list of operations that are available for API management alone, and they are very granular. If you look at it, whether they can create an API, they can update the protocols or the cipher suites and so on and so forth. So you can use all these operations and decide exactly what a particular user can do against your API management instance. That's what we encourage. We encourage to create fine grind roles based on your requirement, and make sure that your API management plane is completely secure for your API providers. Uh, so we talked about the service level configuration. We talked about how we secure the management plan. Now, when we are talking about the full API lifecycle, right? We discussed earlier that here we will design, we'll go into the develop, and finally look at securing your APIs. So at this point of time, we are into the data plane, right? We want to make sure that our data plane is secure, and how we go about securing it using a multitude of techniques that can be employed within your API management, API development lifecycle. I will hand it over to Andre now to go over some demos and talk about a little more on how you secure your data plane. Kim, can you switch the screens to Andrew?
Thank you, Srini. So as Srini mentioned, the data plane security, and remember, data plane is where the gateway component of API management runs. That's where our API are going to run, right? And receive the requests coming from the client devices and users. So what kind of security measure we can take here in order to protect all these different layers in the API management? And then we need to think like this. We have three layers here. First one is the user layer. That's where our requests are originating from. We have the gateway, which is the runtime component of API management. We can call it that. And we also have the backend APIs, right? So we need to be aware of what's happening on each of these layers here in order to see which kind of protection or security we can apply on each of them. So in the gateway part, that's API management. We should perform request authentication. And remember, authentication is the process of proving who you are to the system, right? So I'm Andre, I'm working in Microsoft. So that's who I am, right? That's my ID. And then it also should be responsible to validate the authorization part of the request. And authorization is like proving that you can do the action that you're trying to do in a certain backend API. So validating roles and all these things, So these are the difference between the authentication and authorization part here. And of course, the other responsibility of the gateway part is to validate and forward the requests to the backend APIs. And the backend APIs, first thing here, they should accept requests coming from a trusted source. As Srini said, can either have an internal network configuration here, and then you configure these backend APIs to only accept from the private IP address from API management all these requests. That can be one form of accepting requests from a trusted source. But not only networking level, we also have many other kind of security mechanisms to put here in place. And the other part of the authorization on backend APIs, the API is responsible to perform fine-grained authorization. So let's say the API management policies here are validating, if the users, these requests arriving here, they have the right audience. I mean, it's the target audience is for these applications, right? But then the backend API should validate if the specific endpoint within the API has certain roles to perform that action the user is trying to do. So you can do this fine-grained authorization on the backend API level. And some examples of security mechanisms you can apply on the gateway part. For example, we're going to show these on a demo in a few minutes, okay? So I'm not going into details on each of them, but we have, for example, the default key authentication. We need to make sure that our facade towards the users are well defined and do not exposing so many extra endpoints. We have OAuth, of course. We have client certificate, as Srini also mentioned already, and many others here. I'm gonna demonstrate this in a demo, so just let's hold on for a while. And on the backend APIs, we can do more authentication or authorization mechanism here. For example, we can apply something called managed identity. I'm gonna show you in the demo too. That's Azure specific kind of identity management. We can apply some IP filtering. So we only receive requests coming from the API management gateway. That's one thing. Or secure and lock by using private networking and all these things. And even before the application, the gateway part of the API management, we also can put a firewall. Again, this was also mentioned by Srini. You might have here the API, the application gateway, having a web application firewall in front of the gateway. You might also have the Azure front door to protect your requests before arriving into the gateway. And I'm going to comment a little bit more about this, but the firewall, the WAF, is supposed to protect the APIs in a more generic way. It's going to protect like a lot of things, but not everything. And I'm going to be comment about it in the next slides. Okay, so, and this slide here is about the OWASP API top 10 list. And for the ones that are not familiar with this list here, OWASP is like the top security problems that we have in the web, and in this case here, API application specifically. So these are ranking of the top 10 issues that we should be aware of and taking measures how we can protect our APIs by observing these things. And I have here the list of the top 10 issues for APIs, and also which kind of mitigations API management help us or provide to help us to mitigate these problems here. The first one here, the broken object level authorization. These, we don't have anything, the mitigation API management, because this is what I mentioned before. The API, the backend API is responsible to make sure that I'm performing an object level authorization on these requests. What I mean by that, for example, let's say I'm trying to fetch from API a certain ID, like /ID or something, right? And then since I know what I'm doing, I'm gonna be trying to hack the system, for example, and I change that ID for something else. So I want to fetch that object from another person, or something I'm not authorized to do. If the API is not performing that check, if my authenticated user has permissions to access that object, then I'm gonna have a problem, right? Because I can just manipulate the links, URLs, and so on, and start fetching information from other sources. And this kind of security should be applied on the API level, the backend API level, not on the API management level, because that's very granular, right? But then from number 2 and forward, we always have something that API management can help us to mitigate. For example, broken authentication. This is like, you have a weak password, login/password system that people can just log into the random or try to do a brute force in your system, for example. Or your application is not validating expired JWT tokens. So I can input expired token from last year, and for some reason, my application is not validating that token, right? So I can help to mitigate these issues by implementing some security validations in APIM or API management directly. Okay. Another forms of validation, for example, I can validate a client certificate from an incoming request, or even a simpler key validation that I'm going to show in a few minutes. And then the third point here, excessive data exposure. Well, in this case, think like this. My API management instance is exposing some set of APIs, right, on the backend APIs. And then the developers start to put or add more endpoints into these APIs. Or maybe they start to add more properties inside the object that's returning currently from the API. And these other properties should not be exposed to the end user directly, So in this case here, we have a problem because people keep adding information on the APIs, and then APIM is just responding back with whatever is coming from the backend APIs. And we should do some kind of validation before returning back to the user. The other point here, lack of resources and rate limiting. I think this is clear. I mean, you should be able to apply some kind of rate limiting to your API so people don't abuse it, right? So limit concurrency from their APIs. The broken function level authorization here. For example, it's a similar example as the other I gave here. Let's say that you have a backend API that you're accessing like slash cars, for instance, right? And then a developer go there and starts adding more administrative endpoints like slash admin and so on. And your function, your backend API is not really validating if the role from that token, from that security key or whatever, has permissions to access the admin endpoint. That means you have your authorization, the function level is broken. You're allowing more endpoints to be accessible from your end user, right? And then the other problem here, mass assignment. This is like, for example, let's say that you have an API that returns something from a get, HTTP get statement, like some properties like my bank balance and my username. It's a get, returning that information, right? But then you're not validating if that endpoint is also allowing to post this information back, this data back. For example, instead of getting my balance, I can post my balance from bank account and update that value without permissions. So that's kind of things. I mean, APIM can help you to mitigate this thing by applying request validation. I'm not allowed to do a post on this account object here. Security misconfigurations, that means all these ciphers in protocols are one example that Srini showed. I mean, you should be able to, for example, have TLS or HTTPS on your API management is enabled by default. Do not change this kind of configuration. You should be able to apply some cores that's cross origin requests from one side domain to your API management instance. So be sure to apply all these configurations there. Injection is also very similar here. Injection, for example, SQL injection, right? I'm going to explain in a minute, but SQL injection we can avoid by part of it by using the WAF from application gateway, but also by applying some schema validation to the incoming requests. They also help to avoid injection of not allowed data. One example, SQL injection, right? Number 9 here, improper assets management. That means, let's say that I have a new version of my API, like I have v1 and then I'll have v2, right? And v2 should be the latest in production. And I can see that nobody else is using v1 anymore by using the monitoring features of API management. And then I could just decommission or remove the v1 endpoint for security reasons because it has security issues in first place. And I forget to do that, or I don't do that, by mistake. And the v1 stays there for a long time, and people can abuse the security problems it has and all these things. So that's APIM helps to manage your API catalog very efficiently in this case. And finally, we have insufficient login and monitoring here. Let's say that you have a problem with someone abusing your APIs, right? If you don't have enough login and monitoring in your applications or API gateway, you're gonna have problems to understand what was happening, who was doing things, and so on, right? So API management provides a really rich set of features in order to investigate these issues.
Hey, Andre, I have a question
Yeah.
here.
Mm-hmm.
We talked about the web application firewall at an application gateway or the front door level, right? We know that
Right.
it also addresses the OWASP top 10 in some capacity. How is this different from that?
Good question, Srini. So let me give you my example. WAF is supposed to protect a broader scope. Let's give this example of the SQL injection. a SQL injection looks like very similar to across any kind of APIs, frameworks, whatever, One example, you can put this dash dash and try to make a comment out of your query string and so on. So this is not really different from individual APIs. So all APIs could be prevented from having these SQL injections because they work similarly, right? But then what about the specificness of each API, their uniqueness? For example, I want to prevent my API specifically from getting a specific injection attack that's specific to my framework, to my system even. So one thing I could do is like, I want to apply API schema validation to this API specifically, because I know their uniqueness. I know this can be a problem on my API. So this kind of uniqueness, the WAF, the web application firewall, is not really covering. It protects a broader scope, but each uniqueness feature of each API, then API management help to complement this with specific policies they're gonna show here.
That's
Does
cool.
it
No, we are doing it at a broad level as well as the specific levels. That's very cool.
exactly?
Thank you.
So each one complement the other. Yep. Thank you, Srini, for the question. All right, so the first step here to protect our APIs, make sure that we have a good facade. And what is that in the first place, right? So let's say you have a backend API and want to start exposing via API management. What are the first steps you should be doing in this case? And as I mentioned, only expose an API management, the APIs that the backend API is really having. Do not expose everything like a reverse proxy, right? So be careful to choose the HTTP method supports, the specific routes. Do not expose everything. Be sure to define TLS, enable it or leave it enabled. Define the CORS rules so you can specify which domain can access your backend APIs, and possibly restrict client IPs from accessing your APIs. And if I go now, let me show you how this works in practice. So I think you all you are aware about the OpenAI service that we have in the Azure now, right? And OpenAI is nothing more than an API in first place. So idea here in this demonstration is I'm gonna expose this endpoint here on my subscription in API management. So we're gonna start very raw, very, in a non-secure way, let's call like this. Right, so I have my API demo here, API management instance. Okay, so what can I do to start like from zero, right? So as you know, you can add an API here in API management, and you can just point to some HTTP endpoint. That's it, right? I'm not going to do it now because I have done it before for the demo, because it might take some time, but that's what you get in the end. You get a new API endpoint, point to some place, right? In my case, here's the OpenAI endpoint I have. You have a prefix or a suffix on API management, and that's how you can call it from the client perspective, right? And since I'm very lazy here, what I'm gonna expose all endpoints with wildcard. So in this case here, you see I'm just exposing all the post endpoints from my API using wildcard. That means anything the client sends on their all gonna be sent to the backend APIs. That's it. I'm not gonna check anything else. Okay. If I go back to Postman, so this is my API here, and then the rest of the URL here is like the thing that's in the OpenAI endpoint requires in order to, so we can call it. And I'm not gonna take details how the request looks like, but I'm gonna send this request, and I get a response from the OpenAI here. Okay, I'm gonna just ask for the French translation for good morning, and we got the response here. But that's not the important part I want to show. So if I go to the header of my request, what do I have here, right? I have the APIM subscription key that need to send, and also the API key from the OpenAI endpoint, because it needs API key in order to work. Okay, so that's what I have now. But this is terrible, and the reason is because I know what endpoints I need to expose here in this API. So if I open another link here, for the Azure OpenAI service, we have the REST reference for that one, or the Swagger specification more precisely. This file here describes all the endpoints available and which one, which HTTP variable it has, and so on, right? And you're gonna get a file like this, a JSON file. So if your backend API has, and it should have this kind of, open API descriptor, you should be importing it on API management, just like this. If you add an API, and then you click here instead, Open API spec. So what APIM will do in this case is gonna be creating your endpoints with only the HTTP verbs and then the method names it should support, right? So slash deployment slash something and so on. And this is much better because if you take a look here, this is my other endpoint here that I prepared that is using the schema. So if I try to change, for example, from deployment to something else like admin, this doesn't exist on OpenAI, okay? So it should give an error. So you see 404 not found, and this message is coming from API management directly. This is not coming from my backend API, which should be a problem, right? So that's the reason here that is better, because if someone by mistake creates admin endpoint on your backend API, you don't have a problem because you are describing your API in API management in the first place. So that's how a good facade looks like, step one.
So this kind of partially takes care of the data exposure OWASP.
Exactly, that's part of the solution, Srini, that's right. So next thing here, what else? I mean, if you have, that's not always applicable. But what if we want to protect our APIs by accepting requests coming from a specific IP address only, right? So what we can do here, if I take the third endpoint here that I had prepared, hopefully it's you can see that, but I have a policy called IP filter. So I'm gonna be allowing some range here from accessing this API and nothing else. I also have some cores down here, but the important point is the IP filtering here, right? So that means this IP address will be allowed to access. Let's see how it works. Yeah, I got a response. That's because my IP address is that one. But if I change to something else, so just wait a couple of seconds, stop. Should get the response. Yeah, forbidden response. That's it. You see? So that means I'm locking down the traffic only coming from that IP address. Okay, another thing we can do here, we can also, as Srini explained, add a client certificate validation to this API to lock down the incoming IP connections, HTTP connections from the clients. That's another alternative. So coming back to the slides. Now, the keys, right? I think this was covered on the sessions last week, I guess. The API management subscription key. That's the full authentic or security mechanisms you get on APIs and API management. I mean, you need to send a key identifier as a request header or as a query string, So it's not really fully public accessible when you create a new API there, right? So that's just a way to identify if you have it's coming from a specific developer, coming from a specific application, depends how you configure the subscription keys there in the portal. But I mean, security-wise, it's very equivalent to having HTTP basic, which is like having a fixed or hard-coded login/password. So it's a weak security. Now for JWT, I think this is more familiar with most people. That means you have a bearer token into your request, and then you passes this bearer token as an authorization header into request, right? And then your backend APIs are supposed to validate this bearer token to see if the required signatures, expiration time, audience, rows, whatever, everything is required to be as they are. So that's much more secure because you delegate the authentication part to external provider, and then your application just validates if the incoming request token really is coming from that authentication provider, external provider. Yeah, okay. The client certificates again. Let me show in the portal how it would work if it can add a client certificate. You were there, right, Srini? You just showed before the same tab here. So we can add certificates here. And then there in the policy, you can just call the policy of validating the certificate. Yeah, this one, for instance. So this is the policy name, validate client certificate. So we can just do this and then prevent any request not having the client certificate attached to continue here in the flow. So that's what's doing. Another way to protect your facade or the incoming request from the customers and clients. Coming back to the presentation. Another way we can do to authorize the incoming request, if you're not using a standard identity provider or Vault one, for example, the Azure AD or any other well-known provider out there in the market, we can also forward the incoming request to another service, HTTP service, and then we can get the response back from that service saying, okay, you are authorized or not. So please, cache the result. So the next few minutes containing that same token, that same identity attribute will be allowed to go in without having to call this external service all the time. And this is an example of policy snippet that you can make to achieve that. So for instance, you see this send request policy. This is send HTTP request to endpoint. In this case, it's a Microsoft endpoint here. And then in the body of the request, you could attach, what is the token that I'm getting from the API management perspective. And then you wait for the response, so you just parse the response here and you're checking if the body of that response contains a JSON field called active. If it's false, then you're gonna be returning back from API management, 401 unauthorized because the external service didn't verify that this is a valid token that's getting here. Otherwise, just continue on the flow here. That's not a problem, and you cache the result for performance reasons later. So that would be more of a custom authentication and authorization scenario. And lastly, here I want to talk about the authorizations. This is a feature. It's a pretty new feature from API management. This guy here is actually making it easier for your API management instance to acquire access tokens from external providers using the OAuth standard. For example, let's say that you have a Salesforce backend API protected by Salesforce, and then you want API management to acquire a token in behalf of the user or the application, and then use that token in the flow internally without having your client to do this, So that's a really nice thing that it can manage all the tokens, the access tokens internally in a neat way. I'm gonna show this second. Just a second. All right, so getting back here, let's see the next endpoint. So I mentioned, see the headers of my request here in Postman, That means every time I need to send request here, I need to send the API management subscription key. By the way, it's in here. It's one of my keys here. Okay, so that's the subscription key of API management. That's okay, that's fine. Not strong security. But then Postman, yeah. The other API key, this is coming from the OpenAI. That's a requirement from OpenAI service. And honestly, I don't want my client here from the API management perspective to know which API key the OpenAI is requiring them to use, So I should manage all my authentication stuff inside API management or rely on an external provider for that. I don't want to expose this kind of information back to my clients. So what we can do in this case here, let's first add a first layer of security using OpenID here to this system, right? So that means if I go back to API mem, what I'm gonna do here, I'm gonna use Azure B2C. That's the external consumer endpoint and validate authentication provider we have in the Azure. And that guy is gonna be generating me a JWT token, right? So let's do this. So this is my login page. I'm gonna enter my credentials here. And I should get back, if everything goes fine, a JWT token. There you go. So this is my token that I entered. I'm verified, these details, the claims of my token. So that means I should be able to validate this token using this policy, validate JWT, right? And I just specify what is my OpenID configuration URL for that. So that's the one I got from Azure. And then what is my application ID here, the audience in this case. So not allowing anyone to go in here in this case. So I'm getting more secure now. So that means if I send any kind of token here, oh, by the way, here in Postman, we can just send a bearer token. Let's see what happens. Yeah, I am getting 401 here because this access token I'm using here is expired probably. It's from some time ago. So I'm gonna paste the new one I just generated. And there we go. Now we have proper response from OpenAI and it's more secure now, right? But it still bothers me is the fact here that I have this API key. So how can we secure the communication from API management to OpenAI and don't rely on this API key to be sent all the way from client API management and then the backend, So for that, you can use another Azure feature. It's called Manage Identity. Okay, there we go. Okay, let me run out of time here. Just 1 second. So managed identity here, guys, is like it's an Azure feature that it's able to generate access tokens to communicate internally between Azure services. So I have an identity here for my APIM instance, and it's down here. Yeah, so this is like my username between quotes here for this service in the Azure, right? So this is a managed identity that I'm using. And then I can just go to the OpenAI service there and then enable this API management instance using this managed identity to be allowed to call the resource there, right? So when I do that, I just call the authentication managed identity policy. I say which is the scope or the resource that I want the token to be generated for, you know. And then finally, I just attach as authorization header into the backend API what is the bearer token coming out from this managed identity. And this is the internal Azure header name that goes between the systems. So that means when I do this, I don't need to have the API key anymore because OpenAI will just allow my requests into the APIs. That means I can just remove, the API key and just leave with the APIM subscription key instead. Oh, I need to just paste the token one more time. Yeah. Yep, and there you go, you see. So one less header here that should not be exposed to the client. Now it's removed. I got some slide, but I need to rush a little bit here. So the next theme I want to show you how we can do validations for the content. So in APIM, we have these API, the schemas here, and here we can just add the same OpenAPI specification, the JSON file that I showed you before from the Azure REST reference page as one of the JSON schemas, And then you need to do from the policy inside the API mem, you can just, sorry, not this one here. Yeah. You can just, in the before we send back the response, that means the outbound section of the APIM, we can call these validation policies. This one is called validation, validate headers, right? So here we can just say, okay, if there's a header called OpenAPI model, you can ignore this header, don't do anything. But if you change this to prevent, that means APIM will check if there's an incoming header called OpenAPI model coming from these endpoints. And if there is, you're going to have an error back. It will not be allowed to proceed further with the response back to the client. Okay. And then another kind of policy we have here, validate content, is you can specify what is the maximum size of the request. So if you, for example, you know that your API is supposed to answer or to respond with small payloads like 1 kilobyte or something like this, and then you could use this policy to prevent some, data leakage or something like this by specifying what is the maximum size of these responses. So that's one use, right? And the other thing here, you can validate the JSON schema by calling this policy line. So you just refer what is the schema ID that you upload there in the blade. And then if anything in the response back to the customer contains, something outside breaking this schema here, you're going to have problems. No response will be sent from APIM. So that's a way to prevent, leakage of information there. And finally, I want to show you about the throttling. And this is really good because you probably know that if you're using OpenAI, you have these tokens per minute limitation there, right? So, and depending on the situation here, if I have many users using the OpenAI endpoint in parallel, you can get into the throttling limits really quickly here. So how the API management policies can help us in this situation. So you see this policy here, rate limit by key. So that means I'm limiting something, okay? So I'm going to be limiting the number of calls to 1 in a period of 5 seconds. So the renewal period is 5 seconds here. Okay, but how or what I'm gonna limit in this case? Any request? No, not any request. So we have this property called counter key. And this property is saying, okay, I want you to limit one request every 5 seconds based on my authorization header. Please convert it as a JWT token. That's its format. And then I want you to use the claims OID in this token as the key for the rate limiting. What is happening in practice here is that we are using this unique identifier for the users coming from the Azure as a rate limiting key. In practice, we are limiting, every user in this API gonna have like one request every 5 seconds only, and that's it. So if I try to do more than that, let's see what happens. So I have one, okay, it's okay. Now second request, whoa, I got 4 to 9 too many requests because I sent 2 requests within 5 seconds, right? I'm allowed only to have one every 5 seconds. So that's a way that you can limit your APIs, and prevent abuse of them. Okay, I skipped some slides here because of time. I want to prioritize the demo, but I think I'm back to you, Srini.
Thanks, Andre.
Hmm?
Kim, if you could change the screens. So we've talked about management plane security, the data plane security, and the last component that we want to talk about is the user plane security, right? User plane is where the app developers interact with the developer portal and and perform operations on top of that. So when you talk about the portal, right, we have users in here. API management automatically has user management feature where you can have local users created, right? These are all local users which would be created, the basic users that you see here, and that's included in the identities tab here, right? The username and the provider type, the default provider type is the username and password. We strongly recommend not to leave this provider type because we don't want API management to manage your users, rather integrate with something like your enterprise Azure Active Directory or Active Directory B2C. That way you have centralized sophisticated user management tooling integrated into API management. So once you integrate these identity providers into API management, you will be able to see uh, the portal in such a way that when you open the developer portal, when you try to sign in, you are not actually signing in with the username and password. Rather, you are authenticating yourself with an external identity provider like Azure Active Directory B2C. You can go in here and you can further integrate other identity providers like Facebook and so on and so forth as we go into that. So this is about the users aspect of API management. Now you can also group your create groups, right? If you have integrated Active Directory, you can import Azure Active Directory groups. You can create groups, and not just stop there, right? You can go to your product and assign assign access to those groups, right? You can add, say that, hey, this product is only accessible for by this group of users, or you can create subscriptions. And I had shown in a while ago, you can add subscriptions here and assign those subscription to those individual users as well. So this is all about how you control access to your API management instance. And how you control your users, groups, your identities, um, your identities and identity and so forth. You can also look at delegation aspects. This is one sophisticated one which I wanted you to make a note of. If you enable delegation, you can open up two different delegation options. One, a delegation option when you sign up, so that you can bypass the whole API management option of sign in, sign up, and you can create a whole new experience for your users about the delegation. Again, there's a lot about delegation that is talked about here on how to exactly implement delegation for both sign in, sign up, as well as product subscription. So product subscription is about Take an example where you wanted to take your credit card payments when a user subscribes to a particular product, right? When they go in, when a user comes into your to the developer portal, goes to product, say suppose I look at the product, and I say that, hey, I want to have access to this unlimited product. Probably I'll say I want to subscribe to this, and now you can control the flow of the approval for this subscription, right? You can take them to in a whole together a new experience, try to let them key in the credit card details, make payment for the subscription, and finally be able to create the subscription. So you can control the different aspects of API management throughout the portal settings that are in here. So that's about the user plane security, right? You can also have a lot of advisor recommendations that comes up here. You have advisor recommendations here, and you have defender for cloud recommendations that you can see for API management that shows up in your API management plate. So we have a variety of recommendations that comes up. These are all free of charge. So once you deploy, if there are any misconfigurations, so if you have not used encrypted protocols in your APIs, right? Advisor recommends saying that, hey, you have missed doing something there, right? If you're using a different, if your backends are not authenticated, right? If there is a uh, all scoped API left out without being deleted. So make a detailed review of the recommendations that are emitted out of Defender for Cloud, both for API management and for APIs as well. And at the end, I would like to end this session talking about Defender for APIs. It's part of our Microsoft Defender for Cloud offering, which helps you uh, onboard individual APIs and add additional threat detection on top of your APIs. It looks at runtime traffic, misconfigurations, and a lot of other stuff, and be able to surface recommendations depending on what the usage pattern looks like, right? If I go to Defender for Cloud, if I go to the API section of my workload protections, in this case, I have onboarded two of my APIs in here, and you can see what are the different aspects in which these are being protected at a number of API endpoints. You can see inventory, complete inventory here, right? How many days it is inactive, whether it has any authentication on it or not, how is it being accessed, and so on and so forth. So this is kind of look at the logs, look at the traffic, real-time traffic, and try to surface vulnerabilities in your API management, in your APIs. Again, this is not specific to API management alone, but this is across. This is across for any APIs, but it has a very cool integration into API management, a first-class integration into API management, and be able to integrate with all your security management tools. Like if you have an external SIM integration, you can make that available, or if you want to use it in the Defender CSPM visualization, you can do that as well. A great tool. Again, of late, APS have been a great uh, attack surface for hackers around. So you should definitely look at securing not just your API management, your APIs configurations, and the overall runtime traffic protection of your APIs as well. So at the beginning, we talked about all of these, and at the end, if you look at it, we have made sure that we have discussed security at each aspect of the API management components and how they are being secured, so that we have a secure API management environment to deliver our APIs. To summarize this whole thing, yeah, we've talked about the life cycle. We've looked at how the security is built into every service. We talked about infrastructure level security at the networking level as a service. We looked at individual components, the management plane, the user plane, the data plane security. We also looked at how we can mitigate the OWASP top 10 API vulnerabilities. Uh, that is it for today. I think you had a fun learning experience. I hope this session is useful for everyone. Again, share feedback. We have this is on demand. You can always go to your Learn Live page in here to look at other aspects, the sessions that are coming forward. That's it for today. Thank you all.
Thank you, everyone.